I am going to talk to you about information frictions and supermarkets. Last about prices version, actually. And this is a paper with Pierre Dubois from the Toulouse School of Economics. So there's a large and growing empirical literature on empirical literature on search that you are certainly very aware of. That is in part fueled by the availability of great online or digital data that includes observation on search behavior, or at least search behavior proxied by browsing behavior, and therefore this literature has typically relied on observing search to identify and estimate preference parameters. Okay, but search is rarely observed in typical offline data, purchase data, such as scanner data that we frequently have to rely on. And offline oligopoly markets, and although of course, I mean, online markets have been expanding a lot and growing in relevance, but offline oligopoly markets, and notably brick and mortar supermarkets, is too prevalent and may raise relevant policy questions related to entry regulation, market power, merger control, etc. This add to this the fact that imperfect information on prices is especially important for supermarkets due to their practice of frequently having a temporary reduction in prices, which we call sales. And actually, there is ample empirical evidence that that price dispersion is prevalent across stores and over time. Okay, so recovering consistent demand parameters and measuring the relevance of search costs in these markets is crucial, which motivates the development and the advancement of methodologies that can identify preference parameters even when search is not observed in markets where there is imperfect information about prices. So this is what this paper is going to be about. And what we do is that we develop an estimated demand model with imperfect information on prices when search behavior is unobserved. We recover preference parameters and search cost distributions in this, and we are going to be focusing on choice for differentiated food products sold in brick and mortar supermarkets. Okay, in terms of contributions of the paper, we're going to have not only vertical product differentiation, so products that differ in terms of quality, but also horizontal product differentiation. Okay, so consumer taste, consumers are heterogeneous in terms of taste, and this horizontal product differentiation is especially important in offline markets where there's at least one obvious horizontal dimension, which is the location of the supermarket with respect to where the consumer lives or where the consumer works. So we also combine, another contribution of the paper is that we combine store choice and product choice. So in our model, consumers will have will costly sample across stores to learn prices or indirect utilities of the different products. And once the store is sampled, consumers learn prices of all brands in that store without cost. Okay, so there's perfect information once within the store. There's this stage of perfect information across different brands once you are at the store. And another contribution of our paper is that store sampling probabilities are store, period, and consumer specific. I'll give you a lot more detail on all of that, but let me just preview a little bit the results, empirical results we get. So we get that more than half of the consumers don't search at all and just observe one price, the price of the product that they purchase. Consumers search at most 3 times. This is to say that they observe at most 3 different prices before making a purchase decision. And we also find that consumers in urban areas search more than consumers in rural areas, and also consumers with lower income search more than consumers with high income. Okay, so taken together, this evidence is consistent with high search costs and also high local market power of supermarkets, even in markets that are similarly competitive. So in terms of data, what we use is household level scanner data. So we have a representative survey of sample. Sorry, I don't know what's the surveys here. Sample of French households, and we have in the whole sample, we have information on all food purchases made during 3 years, 99, 2000, and 2001. And we also have information on product characteristics such as price, store where it was purchased, brand, pack size, label, etc. Okay, so we can pinpoint the product at a very thin level. In terms of products that we're going to focus on today, at least, we're going to study beer and coffee. Okay, there are a number of reasons why these product categories are interesting, but one of the main things that these products can trigger shopping trips on their own, either because you've stocked out of coffee, for instance, or because you have a special occasion where you need to consume beer, for example. Okay, they're also products that are highly differentiated in terms of being where brands are quite important. Okay, and then we also use the whole data set of household purchases to non-parametrically estimate the probability of sampling a certain store. Okay, I'll give you also more detail on that. So just very briefly, some summary statistics on the data before we talk about the model. So in terms of household characteristics, two characteristics that we're going to consider to create a household observable type is whether the household lives in a rural area or not. Okay, so here rural is equal to 1 if the household is in a rural area. You see that there's in our sample sort of like half of the sample lives in a rural area, or what we define as outside of an urban center. And what I'm going to be calling rich and poor today is maybe sounds a bit weird, but it's just above or below a certain average income. Okay, so richer or poorer, I guess. And so there's 30% of our consumers that we're classifying as rich or above a certain income threshold. And we have around 11,000 different households. In terms of summary statistics of the transactions, one thing that I would like to point out is related to the number of store visits per week that we observe per week. So on average, it's a bit below 2 or 1.5, but it can actually vary a lot depending on the week and on the consumer. So from 1 visit in the week. So this is here, the observation is this transaction that's why the minimum visit per week is 1, okay, because it's the one that created a transaction, and it can vary up to 10, okay, in just 1 week. So this could be seen as searching opportunities, for instance. And in terms of the products that we looked at, so we look at beer, which is measured in liters, and coffee in kilos. So the average quantity purchased per week per household is around 3 liters, and for coffee, half a kilo. And there's quite a lot of variation on that too. So then, should I be checking the chat?
Could I, Helena? I wanted to yeah. I just have 2 questions. One, you are looking at a cross-store search, and what you call search is basically if a guy or a girl searches more than 1 store. Is that right? Not with in-store search. And the second The second, this is just my understanding. The second question is, I mean, beer and coffee are not really search products, aren't they?
What do you mean? So here, search is for me. I have to go before I make a purchase decision. I do not know what stores are offering in terms of prices because there are a lot of
Searching. I'm talking. Look, when you talk about beer and coffee, I would suspect that searching for a particular beer brand is one thing, but basically this resorts almost to availability because you are not. I mean, beer is a, or both beer and coffee are basically experience products. You want to. You either don't have a taste or you do have a taste for a particular brand.
So here, the characteristic that the product characteristic
is price.
That consumers don't know
Yeah.
before starting search.
Yeah.
Is price.
It's price. Just so price.
I know how much I like the different products or the other characteristics of the product. I know the brand.
Okay.
I don't. And so I don't know what is the price of the different beer products that week, because there's a lot of price dispersion across stores and over time, mainly due to temporary price reductions. That's okay. That I have in mind. So when I make a purchase decision, I'm not choosing out of all the products available out there, out of all the indirect utilities available out there, I'm not choosing the one that maximizes my utility, because I do not observe all of them. I choose the one that gives me highest indirect utility on the subsample of products that I end up observing. That's the idea, right? That's
within that store.
No, within all the stores that I visit. So I go to a store, I pick the product with the highest indirect utility. If I don't think this is good enough, I go to the next store and pick the one with the highest indirect utility until the moment that I...
Helena, can I just ask though, I mean, sort of, I guess, a bit following up on what Konrad's asked. I mean, beer and coffee, I mean, certainly coffee, I would have thought in supermarkets, I don't go to supermarket just to buy coffee or just to buy beer. Yeah. Right.
That's another point.
Is sort of one thing is that these are, I have my weekly supermarket trip and I buy lots of things, and it's a little bit hard somehow to then isolate particular items, I guess, given that it's all about bundles and the cost.
Yeah. No, I agree. So this is definitely a limitation that I'm looking at search for one product instead of the bundle. But of course, looking for search for a bundle can get really complicated very fast. So there's one paper by Wildemans from 2011 that looks for search for a bundle in supermarkets. But then what happens there is that consumers buy the whole bundle in one supermarket or the other, right?
Yeah. But look,
the other extreme and say, well, we're going to search for this one product. So,
and I guess the related thing is beer and coffee. I mean, sort of something special about them that they're very durable or storable. Yeah. Right. So to what extent is that sort of an issue that, when coffee, my preferred coffee brand is on sale, I'm going to buy a lot for several weeks or months and it's sort of.
Thank you, Volker, for almost interrupting me, but I wanted to follow up with a question, namely, if you search for a lowest price, and that was exactly running into your direction, Volker, when I search for the lowest price is very much dependent on the bundle you purchase. I mean, I have written a number of papers on that many years ago, and basically you compare, in some sense, when you search for in a particular store, or you want to search across stores, you compare. Call them real cost of living indices that are related to the entire bundle you purchase within the store, and within this concept, the individual beer price or coffee price are possibly at worst rather irrelevant relative to in their contribution to the real cost of living index. Was I sufficiently unclear in my statement?
Maybe you could, so let me just come back to what I'm doing here and try to defend this. So although I understand that this is, of course, a limitation, not looking at the bundle, I still think it's advancement with respect to demand models that disconsider that when you're making a choice, you're not observing all the prices available in the market. Okay, and so here, the idea that of a story that you could have in mind is that you go to the supermarket a number of times in a week, for instance, and maybe you go in the first supermarket to buy your groceries for the week, and this one product that you purchase, for instance, coffee or beer, is at a price that you don't find reasonable. Okay, and so you wait for the next time, or you go to another store to check if it's on sale there. Okay, and that's why I'm also showing you the summary statistics on the number of store visits per week that would be sort of consistent with this idea that in any case you're going to different stores in a week, and maybe you're going to wait to see what is the indirect utility that you would find in another store for one of these products in your list. So this story would be so my model would be closer to a story like this, for instance.
Okay. And my head are blowing up. Sorry.
Yeah, Martin.
I also had a question. I mean, advertisement seems another issue that is very important in supermarkets, where especially price-sensitive consumers, they might receive these ads that certain things are on sale and know therefore already prices before they go out on a shopping trip. You all the time seem to suggest that you go to a shop to discover prices, but the consumers that are really price sensitive might look at these advertisements already at home and go then to the shops where they know that certain items are on sale. Whereas many others, like say many people in this audience, probably will never look at any price and will just go to one shop and buy whatever they want.
Yeah, certainly this audience probably has a very high search cost, right? But so I'm not assuming that I observe search. And so this is something that I estimate how many prices you would be observing would be consistent with the data that you would observe before you're making a choice decision. So it could be that you're observing prices because you call your friends and ask them what was the price that they saw in the different supermarkets that they went this week, or maybe because you looked at the advertisement that came into the newspapers telling you about the prices. So I'm not saying that you actually got into your car and went to the different stores. I'm just talking about how many prices you observe, but I'm not going to try to, I mean, this is not coming from observing the number of visits to different stores, okay? I'm showing the number of visits to different stores per week just to say, look, clearly consumers are going to more than one store. And sometimes a lot of us is very, cannot believe that people go to more than one store a week, but it does happen quite often. People have this multi-stop shopping sort of.
Can I ask one? So, I mean, I guess you said earlier something about the urban versus rural difference in what you kind of, I mean, I guess maybe I should wait until I ask this question. But you said actually the urban consumer is going to search more. Is that because what you observe is more store visits as well? And
no, this is coming from the model structure and the identification strategy. I'm not using store visits as a proxy for search. Okay. But of course, I mean, it could go either way, because in principle, you could be in a rural area in your car and then you easily go around with your car to do your shopping. But in the end, I think also it's consistent that if you're in an urban area, there's a lot more stores around, and maybe you're going back from the metro, you can stop by 2 different stores going home, right? But this is not this number of visits to stores is not something that I'm using in the estimation.
Sorry,
okay.
Can I have a clarification question?
Yeah.
about the data collection. Are these people who basically register all their shoppings and they submit it to a company for the recordings?
Yeah.
Or is there a set of supermarkets?
No,
which
this
you
follows
observe-
the individual, the consumer. It's individual level, yes.
Okay, so you observe even if I go for one beer into a like local store with a specialized store and buy one bottle, then you observe that because they have to sign, and then you observe these people like for 2-3 years.
Exactly.
Okay, sorry, one more question. If here is like you see the number of store visits, are these different stores when you show this the summary statistics? So unique stores, or if I go back to the same supermarket twice, what would be the number here?
No, this is the number of, I have both, and now I have, and both vary a lot. And now I have a doubt. I think that this is the number of different visits to different stores in a week, different retail chains.
Okay. Okay, thank you.
Welcome.
Just as a reminder, we have about 30 minutes and we should generally save anything but clarifying questions or quick questions until the end.
Okay.
Not to interrupt.
Yes. Okay. So let me briefly talk about the model. Also, I'm going to give you a lot more detail later, but just as an introduction. So the model builds on Ortacio and Syverson, a model from 2004 that they used to study the mutual fund industry. Okay, so it's a model on sequential search for a single item. We add to this observed heterogeneity in preferences. That is, in the end, we have a model that has both horizontal and vertical differentiation. We also add this stage of the within store choice for the favorite product and heterogeneous drawing probabilities. And another contribution of our work is with respect to the identification strategy, because we propose an identification strategy that's quite simple and flexible, and where we can estimate preference parameters with when there's both horizontal and vertical differentiation and heterogeneity in sampling probabilities. Okay, whereas before you couldn't either have vertical differentiation or heterogeneous sampling probabilities, and we can identify parameters with both horizontal and vertical differentiation and heterogeneous sampling probabilities. I'm always trying to, okay. So a bit more on the model. It's a model on discrete, it's a discrete choice demand model where consumers buy at most one unit of the product. We have I different types of consumers in terms of valuation of the product. This is the horizontal differentiation dimension. There's imperfect information about prices at the different stores. Okay, so consumers have to sequentially search for the store offering the highest indirect utility. And once a store is sampled, there's perfect information about products in the store. So once at the store, consumers can costless search for their favorite product, for the product with the highest indirect utility. Okay, so it depends on prices, but also other characteristics. That's why I'm talking about indirect utility rather than lowest prices, right? Search costs are heterogeneous across consumers. Okay, and as I mentioned before, model parameters can be identified when both consumer tastes and sampling probabilities are heterogeneous. So I have this thing on in front of me anyways. So what about product and store level utilities? I'm going to show you sort of the model. So we started with the product level indirect utility for a product B belonging to the set of products in a certain store J. Okay, so consumer I is in store J, and the indirect utility for this product B, there's an issue here. This P should be a B. Can you see when I mark? So this P here should be a B actually. So the indirect utility will depend on observable characteristics of the product that could vary by consumer, by product and by store, common parameters that are time or market variant, the price of the product, and you see that the price coefficient or the marginal volatility of price can vary with the consumer, and then a shock that is consumer, store, and product and market specific, and we assume it to be IID type 1 extreme value. And then the within store product choice, we assume that consumers will choose that product that gives them highest indirect utility within the products available at each store. Okay, given our assumption on the unobservable shock, we get that the indirect utility, the maximum indirect utility at each store J has this typical format, logit format. Again, this is due to the assumption of the extreme value of the epsilon, and plus a shock that is realized once the store is sampled. Okay. So this is what we want to. So this is the indirect utility. Okay. And in terms of the optimal search rule, so a lot of you are probably familiar with this. So the consumers will continue searching until, I mean, while the cost of searching one more time is lower than the expected gain of searching one more time, where this U star here is the indirect utility they already found. Okay, we make the assumption that consumers know the distribution of indirect utilities in the market before start searching. Okay, what they don't know is where to find those different indirect utilities, in which stores those indirect utilities are, but they know the distribution. And we also make an assumption that there's no ties between indirect utilities. Okay, so this means that consumers can rank therefore available products, or think of product store, right? They can rank indirect utilities from the one giving the lowest possible indirect utility up to the one giving the highest indirect utility among all of them. So assuming all indirect utilities are strictly different, there are no ties, then we can write the cutoff points of the search class distribution as something that depends on the probability of sampling a certain store K and the difference between the indirect utility that you already found and indirect utilities above those. Okay, so this search cutoff means the lowest search cost that would lead to purchase in store J, or the Jth highest indirect utility. Okay. So now to go from this from the model to the data, we're going to think about market shares and the cumulative search cost distribution. Okay. So I want you to think, well, you know, so consumers, before they start searching, they already know the distribution of indirect utilities in the market. They just don't know where to find those indirect utilities. So if they find, for instance, the lowest indirect utility, they know this is the worst product in the market for them that period. Okay, so why would they buy that product? Consumers would only buy the worst product, the product with the lowest indirect utility, if they only sample one price, they only sample one store, and they find that worst product in their first draw. Okay, so the market share of the worst product, of the product one, the lowest indirect utility, has to be the probability of sampling the worst product, sampling the product with the lowest indirect utility, product one, times the part of consumers that do not search, that only sample one store. which is given by this here, which is where G is the cumulative distribution of search costs evaluated at the search cutoff of 1. Okay, so this 1 minus G evaluated at search cutoff of 1 is a proportion of consumers that do not search, that only sample one store. Okay, then we can use this type of reasoning to relate the market share of the second lowest on direct utility in the market with the probability of finding that product. So this, who is going to buy the second lowest on product with on direct utility? Those consumers that either search only once, sample only one store, and find the second lowest on direct utility in their first draw, and those consumers that sample 2 stores and find the second lowest on direct utility in the second draw. Okay, and so using this sort of reasoning, we can relate the market shares for each of the on direct utilities to probability, sampling probabilities, and the cumulative distribution of search costs evaluated at the search cost cutoffs. Okay, so let me call your attention to the fact that here market shares and also this the search cutoffs can vary by consumer type and by market. Okay. I'm going to
one clarifying question, if I may.
Sure.
So the sampling probabilities, again, I already forgot simply the sub indices. So they can vary by what?
They can vary by consumer type,
Mm-hmm.
market, so period and region, and week. And, and they are estimated non-parametrically from the whole sample of purchases.
Okay, thanks.
I'm going to mention this again very soon. Okay. So once we have related the market shares with sampling probabilities and the CDF, then we can invert the system to get the CDF evaluated at the search cost cutoffs as a function of the sampling probabilities and the market shares. Okay, so we observe market shares, and if we observed or if we can estimate sampling probabilities, then we could just recover this the CDF evaluated at the search cutoffs. Okay, so that would enable identification of this cutoff points. Then, if we can identify this, the CDFs and the search cutoffs, and we know what is G, we know that we know what the CDF is, or we make an assumption on its distribution, then we can recover the search cutoffs. Okay, by using the equations that we saw before, up to a constant, of course. So what we do in terms of the sampling probabilities is that we estimate them non-parametrically using the data on all purchases. Okay, so we have our consumers, we observe our consumers every time our consumer bought something, some food product, and arrived home with that food product uneaten. And we use that to non-parametrically estimate the probability of visiting a certain store. So there is here sort of an implicit assumption that every time that they went to a store, that consumers went to a store, they purchased something. Okay, and then we make a parametric assumption on G. So today I'm going to show you results when we assume that G is log normal. Okay, but we also have results for assuming that it's uniform and gamma distributed. So we do our estimation using GMM. So we estimate utility parameters, the theta and the U1 are going to be estimated from this moment conditions. Here there's an idea that the error term that is household or a consumer type, store, market specific, may be observed by the firms before they make a pricing decision. So you could imagine, for instance, someone observe a characteristic of the store that could vary also from one period to the other, etc. And this affects the decision of the firms to, in terms of pricing. So we cannot use this orthogonality condition. So we use instruments in this moment's condition. And this is the moment condition that we estimate, where X, our joint product and store observable characteristics, gamma T, or a time period fixed effect, so unobservable shocks that are common across different stores and products, and Z is our price instruments. We're using here a function of prices in either other markets or by other consumer types. So they're going to be correlated with the cost and prices of the products, but uncorrelated with the add-ons that the store may decide to consider because of shocks to the store and observable characteristics of the specific store. And then in terms of consumer type, we consider a combination of whether it's the consumer is high or low income, and whether the household is in a rural area or an urban area. Okay, so I'm going to show you results in the end. I think that those are results for beer, for instance. Here I'm showing you the CDFs evaluated at the search cutoffs, search cost cutoffs, and I'm showing you different for different consumer types. So poor, again, like low income in an urban area or in a rural area. And so, for instance, G1, this is the height of the distribution at search cutoff point 1. So this is a measure of the proportion of consumers or the proportion of purchases that were made when consumers observed at least one price or searched at least once. Okay, so 1 minus G1, so for instance here, what would be around 60% would be the proportion of purchases that were made when consumers did not search at all, just bought the first quote that they had. Okay, observed only the price of the product that they purchased. So we can see that around 60% of lower income consumers, or 65%, depending on urban or rural, do not search at all and purchase only the one product that they sample. And the proportion of higher income consumers or that purchase more than once is lower than for poor. Okay, and this decreases very fast, and there's basically no one going for more than four prices before making a purchase. I'm going to talk a little bit more about these results. So let me just show you coffee, and coffee looks quite different. So there's also evidence here that search costs can be different depending on the product that you're considering. So search costs seem to, or consumer, there seem to be less search, or consumers are observing less prices before making a purchase decision for coffee than for beer. So the proportion, the search cutoffs at 1, for instance, is much lower than for sort of half or 1/3 than for beer. So interpreting how to sort of read these tables, I have this table here, for instance, that shows that for beer, this means that a low-income urban consumer will, around 60% of them will never search and just buy the first product that they see, okay, the first draw. So this is consistent with very high search costs, and it's not very counterintuitive, because we all have this intuition that we're not visiting 150 stores before, buying beer, I guess. And around 22% will search at least once, so observe at least 2 prices before making a purchase decision. Then 11% would search twice, and then this more than 3 times just never happens. Okay, and then another thing to note is that a poor urban consumer seems to search more. There's more search activity going on than a rich rural consumer, for instance. Okay, that also makes sense. So urban consumers seem to be searching more than rural in general. And this is the same table for coffee, where we see that nobody searches more than twice. So there's less search activity apparently going on, or less prices that are observed before making a purchase decision when you're considering coffee compared to beer. And there's really a big part of purchases that are made when consumers observe only one price. Okay.
Sorry, just a question. How do we know that these are significant, the differences?
So
is this?
I don't have any statistics on showing that those are actually different. I'm just giving you some proportions. And I mean, it seems that the direction is in the direction of more search going with urban than rural consumers. But I could probably do something with respect to that too.
Okay, thanks.
Okay, and then we get from here we can get to the estimation of utility parameters. I'm not going to show you all utility parameters that we recover. I guess the most important ones are the price utility parameters. And here, of course, we have significance. So also we have different price parameters for depending on the type of consumer. There's some evidence that, it's also sort of intuitive that lower income consumers are more price sensitive than higher income consumers, and this both for beer and for coffee. And just to note that these estimations, these regressions include store, region, and period fixed effects and other product characteristics. Okay, so in the end, we were quite good with, I mean, maybe quite good with time. Dan, so I showed you an empirical strategy to estimate the magnitude and the distribution of search costs. We allow for both horizontal product differentiation on top of quality differentiation among products. And we have a model that combines store choice, which is costly. There's imperfect information about prices offered in each of the stores, and within store product choice, which is costless. Okay. And then there's store sampling probabilities, which are store and household specific, and that are recovered from the data on the whole sample on food purchases. We find empirical evidence that is consistent with with high search costs, and with consumers not observing many prices before making a purchase decision. Of course, here the idea is that in a traditional demand model, we make an assumption that consumers observe all prices available, at least all indirect utilities, and then choose from all these indirect utilities the one that maximizes, or the highest one, the one that maximizes their utility, right? Here, what we are showing, the empirical evidence that we find is that, on the contrary, consumers seem to observe very few indirect utilities in the market before making a decision. Okay, they're very far from observing all prices available in the market. They seem, most of them observe only one price before making a purchase decision. So this is consistent with search costs being very high, or imperfect information about prices being very relevant, right? Otherwise, we would find that they observe everything. They search all the prices before making a purchase decision. And we also find evidence consistent with lower income consumers searching more than higher income ones, and being more price sensitive, which is of course part of the same story, and more search going on in urban areas than in rural areas. Okay, so also more price sensitivity in urban areas than in rural areas. And that's it that I wanted to tell you.
So thank you for a great presentation. We're going to open it up to questions, and people can unmute and ask as they
Okay, should I stop sharing the screen?
That's up to you. If you want to use slides as you answer, yeah, leave it up. If not, take it down.
Okay, let's see what the question, if the questions require that. Otherwise, I'll take
Can
that.
I ask one thing about, I mean, which is probably more for concern for beer than for coffee, is about just the quantities. I guess you have a discrete choice model, right? You either buy or you don't. So you buy, yeah. Implicitly in the theory, it's 1 unit. Now, of course, that's not quite the case, right? And, you know, you buy, you know, maybe individual bottles, but 6 packs or even bigger quantity, you know, and so on. So I'm just wondering how you deal with this. And, you know, could also imagine that obviously there's a big difference between, you know, purchase in the supermarket.
So my product definition includes pack size. So 1 bottle is a different product from a 6-pack.
I see.
So of course, I mean, if you buy 3 6-packs, then this is a bit harder. But the way that I deal with, or that we deal with this quantity differences in discrete choice models, is sort of try to include it in the product definition. That's what I do.
So in some sense, it's a horizontal differentiation rather than, you know, you could also have imagined it's, you know, more in the logic, I guess, of storable goods, right? That, you know, I buy more, therefore I have to go, you know, less often and so on. And yeah, I mean, it's sort of a more, or I can, I mean, I guess there are these models, Metchensk, I mean, about, you know, is it 1 unit or do I buy 2 units? So it's, you know, it's more in that. So I'm just wondering what here, you know, when we think about search cost, that seems kind of a salient feature, right?
The size.
Yeah, the size, you know, the number of units. Of course, at the same time, you have also different family sizes that obviously, you know, it's not easy. Yeah, I'm not sure. But,
yeah. No, I'm definitely sympathetic. I mean, stockpiling is something that interests me, and I have work on this. And when we're talking about supermarket products, you know, except if you're talking about lettuce, I mean, you can typically stockpile, right? And there are products that you can stockpile, and this is something that we have had to have in mind, of course. But considering including stockpiling in the full way with this within the search model would be interesting, but maybe a bit too much, I think. So we're sort of not thinking about this now. Yeah.
I mean, I guess partly, I mean, sort of why did you choose these goods rather than milk or something more perishable? Maybe it's a bit of a
milk. Yeah, so milk, for instance, is not perishable because it's usually UHT milk. Milk is not. Yeah, I tend to think of milk as very homogeneous. I wanted something that was highly differentiated, where the choice across different brands was relevant too, right? And accordingly, milk actually has. I think I've looked at that. I may be wrong, but I think that there's less prices Persian also would also be consistent with being less branded, more homogeneous, right? Yep. So one of the things that we were looking for were products that were highly branded, where brand makes a difference. They're very differentiated.
Helena, this is Bart Brandenburg. Hi. Thank you for an interesting talk. I was wondering, you're using Hausmann instruments to, you know, to essentially to create a orthogonality condition in the GMM. In a country like France, where, you know, you have national retailers, you know, how realistic is it that those prices are going to be uncorrelated across markets?
So what we are using here, so the results that I showed you today, let me check exactly what are the ones that we used. We used the average price paid in the same market by the same type of household in different stores. Okay. So those are stores, for instance, that either didn't have a sale or didn't have that store-specific shock that has that may have affected the decision of pricing of Carrefour, for instance. So we looked at bar type of consumer purchase, what is the average price they paid for coffee in that region, in that geographical market, but in other stores. So it could be correlated with the price of the store I went to, but uncorrelated to the temporal shock that is specific to that store. That could be, for instance, an observable characteristic of the store that is constant over time, but it could also be, I don't know, some promotions in other products that are happening at the same time that are affecting my pleasure of shopping at that stores.
Okay, and you're saying other stores, does that mean other chains?
Yes.
I guess my primary concern would be that you shouldn't be sampling from other Carrefours in the neighborhood or in close by.
No, right? Other chains. Sorry, other chains. Yes,
thank you very much.
The other instrument that we are also using, the results that we showed today, that I showed today, is other types of consumers. Average price paid by other types of consumers in the same geographical market.
Okay.
So I think that we are sort of safe from national pricing, although there's a lot of difference in assortment between stores, even with the national pricing. But
can I also ask one? So again, the consumers that you say that don't search, they actually in your data go to one supermarket chain even and purchase from there.
Exactly. Yeah.
So they could go indeed, first of all, to multiple supermarkets within the same chain, or to and that's within a week. Is that the case?
No. So again, we don't use for identification the store visit. Okay. Mm-hmm. We just relate market shares of the different products to sampling probabilities, and the sampling probabilities use store visits for the whole sample, and the CDFs at the search cutoffs. So what I'm saying when I say a consumer doesn't search, I'm mm-hmm. saying that consumer purchased, only observed one price for purchase, only sampled one product. Okay, that product that consumer purchased, didn't go around and looked at the prices of the other stores. That could be visiting the different stores or calling friends or looking at the newspaper for
okay. So this comes from this kind of, okay, so this is, you kind of recover this from this other things.
Yeah.
Okay, but and okay, so then let me ask you a different question. So if you, for example, buy lunch in a supermarket, I don't know if it is relevant in France, but whatever, and then you never make it home, obviously, with the stuff to scan it.
I don't have this data. No.
Yeah, exactly. So then these kind of things are probably does that affect your estimates basically? So.
Yeah, I mean, definitely there's error in this non-parametric estimation of mm-hmm. the sampling probabilities, right? Because there could be different visits to stores at different periods by different consumers that didn't generate any purchase that arrived home.
Exactly. Yeah.
And okay, so I'm missing this, but.
And does that then mean simply that you underestimate the amount that people search?
Not the amount that people search. So for the results on search that I give you, mm-hmm. I don't need, what I could be underestimating is sampling probabilities. for a store. So the sampling probability, so I find that rich urban consumers in a certain period, the probability that they sample a Carrefour in their area is, I don't know, 0.1, 0.2.
Mm-hmm.
If in that data, there's a lot of people going, a lot of urban rich consumers going to Carrefour and not buying anything in that period, then I'll be underestimating that probability, right? But I mean, it's okay to have errors. What I cannot have is like error. There's more people going to Carrefour and not buying anything than going to Auchan and not buying anything, for instance, or more urbanites visiting a store and not buying anything than rural. Then this could create some bias.
So there are, I do think that there might be differences with respect to these consumer types, in the sense that if I'm an urban one, probably like shops are on my way more, so then I'm more likely to visit there, and then that not get recorded, that doesn't get recorded. And probably also as a poor person, if you wish, because then you do the window shopping if you wish more, and then, but I don't know how it affects your results, and it might be that you just, they go in the right direction, but it's just something that I wanted to highlight.
Again, so I can think more about it, but I think the examples at least that you gave, so urban, if it affects all chains the same, I can.
That I'm also not sure, because the chains usually are also that, you know, there are more urban chains and then there are more rural chains, like Lidl, who has all the stores somewhere outside, right? Again, I don't know the French supermarket market so well.
True that Auchan is just not in the city center, whereas you have Monoprix in the city center, for instance, right?
Yeah.
So there are, in terms of locations, you're right, there are in France very strong correlations.
Yeah, it's true. This is maybe something, indeed, Eva, thank you, that we should investigate further. I mean, if it's more likely that in very small stores you could go in and not find what you want and go out without, then it means that we could be underestimating for these stores, sampling probabilities. Yes, and this is something that we are not doing anything about currently. We should probably investigate further. Thank you.
Okay, thanks.
Just one thing, I mean, this is a really large sample, so we'll still think that we are missing very little because I mean, it's like all purchases and there's really a very large number of consumers. So I showed you result for 11,000, but when we do this non-parametric estimation of sampling probabilities, we use like around 60,000 consumers. So even if, we're missing some visits, I think this is small. I don't believe that, although I don't have anything, systematic to show you, I don't believe that there's a lot of bias coming from there. Yeah.
Are you able to say some things about search behavior over time with your Goliath data set? What are these individuals doing? How do they respond to when all the temporary sales come out? How do they learn over time where the cheapest stuff is? I mean, can you look at how this search behavior changes over time with respect to some interesting things?
So just to be sure, I don't observe anything related to search. This is something that comes out of my estimation. So the idea would be to try to relate.
Can you estimate how it does that?
Yeah, and then relate this to observable sales. I think we could, we could take a look at. Thank you. Yeah, that could be cool. Yeah. Thank you.
Okay, I am gonna stop.
Can I just say one more random thing?
Yeah.
Do you have some expensive goods that people buy frequently? More expensive than the stuff you've got, beer and whatever. Have you got something more pricey that is also interesting for you in terms of the differentiation? But
yeah, so
it's more of a meaningful part of Conrad's bundle. A big part of it.
Whiskey.
Yeah, we do have whiskey. I mean, we do have results in whiskey. So whiskey is one of the products that we look at, and the reason we chose to look at whiskey is exactly to make the difference between the cheap beer and the expensive whiskey, right?